Over the past 4 months, Auxiliary Robotics has dealt with unprecedented, yet predictable hardware issues. The team has undergone several hardware changes to come up with Alfred. What you see before you has gone through iterations of hard labor that has made this demo today possible. Last week, you saw some faults that we worked very hard on mitigating. We now have recovery behavior and grasp success recognition. Our HRI is now better with a better background noise cancellation system. Thank you for attending, and we'll see you all at the fall validation demonstration where we'll be bigger, better, and stronger. This has been a BenAb, Ravi, Shaolin, and Shiva. Follow our Twitter handle to stay updated.
No need for a demo. That was excellent. How'd you get that voice?
It's AI generated.
Okay. It probably was.
Okay, so with that, thank you all for joining us. We're Auxiliary Robotics, and we're propelling assistive healthcare into the future. So this is our team. I'm Shivam,
Shaolin.
and we're building Alfred. Alfred is a friendly indoor robot that provides low-risk assistance to patients in elderly care environments, and it improves health monitoring. So we're going to have a quick presentation before we get on with the demos, the good stuff, starting with the motivation, right? Why do we need Alfred? There's a huge labor shortage in the assisted living industry. In fact, since 2019, around 250,000 caregivers have left their jobs. Why is this? Well, it's due to challenging work hours that they face, the inadequate pay, and the lack of respect and recognition in their environment. Senior citizens are among the fastest growing demographics in the country. And so this is a very alarming issue. In fact, it's predicted that going forward, 7 out of 10 people will require assisted living care in their lifetime. With Alfred, we want to provide a long-term solution. So how does Alfred empower caregivers and reduce their workload? Well, here's an example. An old lady here asked Alfred for some help. So Alfred can fetch the water bottle. It can get it back to the old lady. Just like this. So Alfred can fetch requested items, right? This could be a water bottle, this could be medicines, this could be fruits. What else? Alfred can also interact with the user. Now I'll pass it over to Shaolin to explain how it works.
So now you know what the motivation behind a project is. Now I'm going to dive deep into how exactly these subsystems work on the robot. So first of all, we're going to talk about HRI. As you can see, for the human-robot interaction, you need to have some visual aspect to it. So here are some eyes expression. The robot is not listening right now, so it's kind of drowsy. And then there is the communication aspect of it, in which you ask it to do something, and it also communicates with you and understands tasks that it needs to perform, powered by ChatGPT. It has a video call modularity as well, which is all powered by Agora. And then lastly, if a distant loved one wants to control the robot in the periphery of the patient, they can do that using the teleoperation feature. And then onto navigation. So once we have the robot, how does it understand what environment it's in? Well, it has a LiDAR here, a 2D LiDAR, which can sort of throw rays around, get an idea of what the map it's in. And this is the map we had till last week. Now, all of us saw that there were some localization issues. So what we did was, instead of drawing a line on the map, we ended up remapping the whole environment. So rest of the things remain the same. There's all of you. There are the 3 of you. And if the robot is given a goal location, move base uses the global planner to plan the path. If there are obstacles on the way, it will avoid them using the DWA local planner. And then once it's in the periphery of the object, the manipulation pipeline is called, and it detects objects using YOLO V8. One thing that happened last time was, although the grasp pipe recognition pipeline ran and the placement pipeline ran, the object was not detected. So this time, what if the object is not detected and it goes back and executes the same pipeline? We don't want that, right? There needs to be a recovery behavior. So this time we have included at least around 2 or 3 attempts before it actually gives up and responds to the user that I could not find the object. Other than that, if it runs smoothly, if it's able to find the object, it'll give a grasp, the grasp pipeline will be called, and then the manipulation planner will go and fetch the object. Now there's another condition here. We're going to check if the grasp was actually successful or not. If it was not successful, which can happen in cases like these, it will reattempt again before declaring failure and giving feedback to the user. And if it actually goes well, then the navigation and placement pipeline will be called, and the robot will go back, perform ransack for plane detection, place the object on a table, and yep, that's the task done. So now, back to the demo. Hey, Alfred,
Hey,
I want to video chat. Hey, Praveen, did you push your code? Yeah. Okay, cool. That works. Cool. This is being teleoperated by Praveen. Hey, Alfred. Hey, Alfred,
yes.
stop video chat.
Sorry, I didn't catch that.
Hey, Alfred. Hey, Alfred. Hey, Alfred,
Hey,
can you please stop video chat? Okay, it worked.
I apologize. Is there anything else I can assist you with?
So we'll reset it for autonomous mode.
He
here
already-
itself? Hey Alfred. Hey Alfred,
Hey,
can you get me some water?
on it.
So the robot is supposed to go at that location, find the bottle, align itself with the bottle, manipulate it, and place it back here. Currently, robot is running visual servoing algorithm. As you can see, the camera is scanning the whole place and trying to find where the bottle is. Later on, it will try to align itself with the bottle such that it is within the graspable pose. So robot has found the bottle now. It's going for the manipulation. Robot has successfully grabbed the bottle. It will come back to the placing location here. So right now it will try to find the plane of the table and will try to place the bottle on the table. It has detected the plane of the table now. Yeah, so there was some problem with the manipulation pipeline. It ended up dropping it.
But placed it.
Yeah.
Here's your thing.
Thanks, Alfred. So we'll try manipulation on a different object right now. As you can see, there is a banana on the table. And this is slightly more complex than the objects we have shown you for SBD because of the curvature. Hey, Alfred,
Yes.
can you get me a banana?
Sorry, I didn't catch that.
Hey, Alfred,
Hmm.
can you get me a banana?
Let me get that for you.
Meanwhile, we can take up questions from audience if you have any. Yeah, sure.
Like
So
after retracting these? We're just doing it for safety concern because in extended arm, when it's navigating, might collide with other objects. So we thought it would be safer to first yaw it and then store it basically as low as possible.
What was the issue with the manipulation pipeline that caused the?
So when the robot grabs the bottle, as you might have seen, the bottle was slightly tilted. So when it placed it, since the bottle was tilted, the center of mass, basically it fall down. If it had grabbed in a particularly vertical position, it would have been okay.
So this is the problem with the design of it for itself. So you have like, okay, so here is the case where the robot is actually not found the original.
It's
So it's going to wait for some time. Okay, and banana is not in field of view, and
So let's say if we add a new object to the environment, let's say if I had a coffee cup, what are the steps that are required to get it done with the whole audio thing?
Oh, it's actually very simple to do. One thing is just first align the we have to add the primitives for everything into our API, and then once that is added, then yes, the robot actually kind of knows where what commands to map to what object. After that is done, we have to also like currently we are assuming that there's a rough area and one object, so that has to be added.
So if you notice last week when the apple was not found, it just returned with nothing. Now it performed a recovery behavior in which it found it by rotating its environment, and now it's able to actually get the object. This is an improvement.
Yes.
They were trying to figure out from the geometry what is the best place to pick
Uh,
the object.
We are actually running a deep learning model, GraphNet. So if you give the point cloud of the object, since it has been trained on billion graph poses, it knows what graph poses are good relatively to others.
So
So
in the earlier bottle case, it was the bottle bit lower.
sorry.
In the previous one, then it did not try to correct it. Seemed like it tried to grab the bottle around the sort of the neck of the bottle. But
Yes.
a lower position. would have-
Yes, the system is still not perfect because GraphNet gives you 6D of poses. We'll have to do corrections to make sure that a 3D arm like this can grab different objects and fit on.
So you can see that the paper itself is inclined at an angle, and that so means the graph. If the graph is not exact, then what happens is that the object you're grasping itself is tilting, because you can see that when the graph is happening, it kind of pulls the object inside, and that's what is it. So we might actually go to a slightly advanced version of the paper, which allows us to grasp the object in a very horizontal manner. Might help us a bit.
So
Do you
now
close
it
the
detects
gripper
the-
fully, like when you grab the banana, or is it like current feedback and you stop after a while?
No, we close it fully as of now.
Okay.
Yeah. So the robotic successfully placed. Thanks, Alfred.
Can you do if the bottle was a plastic, one of those squishy bottles, would it impact the?
Next study.
I don't think it will impact right now because we are going for the full grasp. We are not calculating how much we should contract the gripper.
Crush the bottle.
Yes.
Yeah, it's, yeah.
Hey, Alfred,
How's life?
can you get me an apple?
I'm not sure what you're asking for.
I'll have-
Can you please provide me with more information or a specific request?
So it's made for old people, so it has some hearing problems. Hey, Alfred,
Hmm.
What do you mean?
just a so. Hey, Alfred,
Sorry, I didn't catch that.
Yeah, of course.
hey, Alfred,
What's up?
can you get me an apple?
I'm sorry, but as a robot, I am not able to physically transport objects or individuals. Is there something else I can assist you with?
Yeah.
Let's give it one more try.
You got me hacked, my friend.
Yeah, anyone from the audience.
Yeah.
Yeah, okay, Kevin.
Come on, Kevin.
So you're first supposed to say the wake word, which you know. Don't say it now, otherwise it'll catch it. So,
Okay.
and then
I
you
can ask for anything.
Or ask for anything. Can you get me an apple?
Hey, Alfred,
Hey,
can you get me an apple?
I'll do it right away.
So apparently it's not very loyal to its creators. It's
Kevin, you are aging.
It only speaks robot, so.
So as you might have observed, last time robot was having difficulties navigating this particular area because of the changes in the map. But now we have managed to fix it, so the path it is following is actually pretty smooth now.
Can you explain what are the changes that you did in the navigation system?
Yeah. Shivam, you want to take that question?
Yeah. So for the navigation side of things, what we did is we marked these areas as unknown regions, and then we had to tune the parameters such that it is a high cost for planning paths through these regions. Essentially, it plans through this.
So just in case somebody else stepped in and.
Yeah, oh yeah, and that's sort of our next thing, right? Once we're gonna put obstacles in. Yeah, you go on, shares.
So how did remarking the environment change anything?
Yeah, so we actually I think so, Sharon, what we meant was we actually edited the existing map that we had by marking those areas as gray. So essentially the cost map has three regions. One is black for obstacles, white for paths it can move in, and gray for unknown regions, right? So that's sort of we can use a editing software.
So right now, robot is trying to find the object. And in the first go, it couldn't find it. So we are running a recovery behavior right now where the robot will scan the whole place and figure out if there is any object in the vicinity.
And instead of going to this table, it directly went to that table, which means like there is some definition of
Yes.
area to solve.
Yes. For this project, we wanted to create a structured environment initially because that is what we expect in assisted living facilities. That was primary our use case.
So kind of like food in one location. Books or
Yes,
something.
exactly. Yeah.
Yeah, got it.
So it has found the apple because of the recovery behavior right now. And it will go a little close to it. It will visually align it.
What was the recovery it had to do? It was looking in a general area where it didn't find an apple and it has.
Yes,
different area?
yes,
Is it 360 actually? Did you look at
yes.
Nice thinking.
So,
Kevin, what kind of problem did you ask? Make sure up and up doesn't hit the apple.
okay.
Maybe the robot is a friend.
So
Yeah.
we start the apple trial. Is that correct, Praveen?
We found it.
So it's
So-
just
so
still
what
running the
happens-
recovery video. Sorry.
What happened?
I think the
We've been having some internet issues with the brain, so what happens is that actually it's running the your text algorithm, and it loses connection and that kind of makes the entire process start going.
but it's still trying to find the apple again, and if it finds it, it should be okay.
It seems back. Yeah.
Huh? It's back. Yeah, it's found the apple now. Now it is done.
Oh, it's thinking now.
Yeah.
It's gonna change the flow of human history. We fix up that apple.
Yes. So let's see if Alfred is able to pick up the apple or not. It has detected the contact of the table as well, and
And it picked up the apple.
Yeah, I think no. So there is some. So there is some hardware problems with the platform. So even when you command it to go back, sometimes it doesn't. So that was. But I think it should successfully place it on the table.
So when it's in recovery mode, and if I hold the apple in my hand in front of the camera, what is expected?
If you hold the apple in front of it in your hand,
Like if I force it in the field of view and it does detect, so
yeah, it will detect. It will detect.
will like servo and go for the glass.
Yes.
But there's no plane detection. So you can actually
Huh?
see the visualization of the plane detection.
We are performing plane detection. Yes.
So from hand it takes it, right?
Yeah, plane detection. It will go for centroidal grasp. So that is our recovery behavior. If GraspNet pipeline fails, it will go for the centroidal grasp.
I think it's only gonna surrender the apple. So Kevin.
Do I step forward?
You should head to the table. Yeah. Be careful with that.
You deserve your apple.
Put it on the table like that. No, we give it to you. Don't squeeze you a little bit.
Don't bother about eating it. It's been there for like 2 months. Get sick.
I guess so. Like after the game, we can have people in the audience ask for other
Here you go.
other objects.
Thanks, Alfred.
I think it'd be good to try either the water bottle again or some object that it needs to stand up.
Water actually. So
Yes.
Different word.
Yeah, you want to, yeah.
Huh?
Okay, so.
That pepper river water. This is
Guys, can you take a dynamic obstacle which is Hardik?
Yeah, sure. Please come inside. So that might not really work because our depth camera is used for.
Hardik, do move around. Do move around. You are a dynamic.
this might still work.
I think that.
Okay. Yes. So while
I think you can do longer.
Yes, yes.
Okay.
Hi, Alfred.
What's up?
Can you get me a water bottle, please?
Certainly. Where would you like me to retrieve the water bottle from?
So
The
it's
table.
Alfred. Hey, Alfred. Hey, Alfred.
What's up?
Can you get me a water bottle?
I'll do it right now.
Could ask, do you want me to bring two by? You guys.
You have to be more patient, and it is one of the way we can, take more care of old people. So
I think you have been visiting a lot of.
no.
So that's it. So it can only move.
I think a dance step.
Okay. Okay, let's see what happens. I think this is too hard, but it probably.
Let it run. Let it run. I think it should be able to navigate.
It's really trying to go.
Yeah. It has two kinds.
Yeah. It's actually going back to see backtrack, see what happens.
Yeah.
Okay.
Wait, let
Let it go. Let it go. Let's see.
Yeah, that's a dance step.
Yeah. So it's finding the same path again, apparently, through that narrow passage.
It's fine. You know all.
Now it's gonna change.
Is that Alfred's brother?
No.
Yeah, it's like it's very hard.
I think the footprint is just enough to like make it fit to that, and it's like this, like all it.
Yeah. So now Alfred will be able to find a path.
Nice.
We are gonna try one more thing. We'll change the location of bottle dynamically as it is going for manipulation. So let's see if Alfred is able to adjust for it or not.
So does it see this as a bottle of water?
Okay, it's not being detected, so let's try to make it.
Yeah, so- no, that
Don't
won't
spill
work.
it. Yeah, don't put it in the liquid.
Yeah, that's a good one.
Yeah, it will work.
Okay.
So Alfred has detected the bottle.
Try messing it up.
So does
So-
it detect
So
It's aligning with the bottle again.
But you saw the first time, right? First time, like,
Sure.
the glass is perfect. So it's bending. So it's
Yeah, it's fine.
So this is a common thing with bottles, like why does it hold on the outer side? Maybe that's why it's tilting a bit.
Yeah, so I mean, the depth has to be exactly correct. So, like the real sense is not very, so actually you add in the back, so the background at least gives a full context for how far the object is away from the camera.
Let's see if it can avoid this obstacle. I hope it does.
What's the height below which you would have detected the object?
So basically, whatever LiDAR height is there, below that, any obstacle will be there. So
Yeah,
basically, my
let's
shoe won't
mess
be
with
detected.
Alfred.
And for houses with sort of bumps between the rooms, if you can stop hearing them.
Yeah, yeah. So the bumps will affect it. So that's why we don't try and run it on the carpet because it does affect the geometry.
If you get this hard, it won't pick up the next object.
Yes.
What are the chances that it avoids my leg?
You can add that.
Are they tall enough?
We haven't tested.
Well, I'm just taking a nap.
Yeah.
If he ever gets,
If you were baby hard, they.
if it ever gets here, I mean,
Let's see.
Oh yeah, this is so we haven't tested this. Just sort of trying to see how far it goes.
Yeah, so as you can see, it tried to go on the carpet, which might have made some changes to its odometry.
Yeah, I think it has a wrong estimate of its own growth rate.
Okay, maybe that is strong dishes. Does that work?
Yes.
Okay.
Okay.
Well, I mean,
Oh.
God tested to limit. That's not. We can do one more with a bit, maybe a bit more. If anyone else wants to see it, try it out.
Maybe the other.
Yeah, let's do the apple. Anyone from the audience at the back?
Matthew, you want an apple?
I can do it.
Yeah, come.
Yeah, it's like, but
Yeah, come here.
Come here.
From there.
in here.
The green apple.
Hey, Alfred. Yeah, sorry. Went to once.
So it might fail in those times because ultimately it's learning by learning. It won't be able to detect the object if it's close so much.
So for example, if you can see the top of the bottle, you have an
So if you have just a small object like an apple in front of a bottle, it will work fine. But if you have something, let's say a box in front of a bottle, then it doesn't have access to the control of the whole bottle. It can be detected on.
Let's be clear.
We haven't included obstacle avoidance while manipulation in the pipeline.
Let's start.
Yeah. That task we have.
Okay, Sandhya is going to try asking for another apple.
Hey Alfred.
Go again.
Hey Alfred.
Alfred is sleeping, as you can see from that.
Try.
Should I be louder?
No, just be louder.
Hey Alfred.
I think your voice is pure and high pitch for the.
Try one more time. Wait. Hey, Alfred, be polite.
Hey Alfred. Can you get me an apple?
On it.
Two commands.
So, Vivek has said the apple according to this discussion is somewhere on the edge.
Okay.
He's the classmate and he puts the app.
If it's extra, Vivek has to eat the apple. And brings it here.
Even from the audience can like one mess around with the can start.
Yeah.
It's just.
You raise the app. That's so rude to do.
I want the apple on that plane than the surface, so I put it on top of the water bottle. So you cannot.
The host is using MC.
So what is like now that I'm trying to detect the average, there is a obstruction part of the camera.
Yes, like we
Going
and if the communication is lost, we have a different behavior altogether. Like yeah. Huh? Sure.
I'm not sure how it
But chair does not have anything in the bottom for light.
Yeah, right.
Optical, yeah.
So the problem is because of this chair is pretty sleek.
That lights it has to stay. Maybe you can also keep those boxes if you want to remove that, like so.
Yes.
If you want to do it, yeah.
Yes, so this apple is.
The apple walkout.
Yeah, actually on the wall. Only
You love a lot.
Okay, we're trying to go there.
Just to put on record, that was part of some other ghost project that is going on, so you're not surprised.
Wow. Okay, he totally ignored you there. Thank you.
Yeah, so.
Yeah, so the moment it gets on the carpet, it sort of moves around.
Good prize. Great job.
So right now it can detect about 80-90 objects which are part of the COCO data set because that is what we have trained on. But we are also building our own custom data sets which are more inclined towards what you see in assisted living.
Okay. So, all right. Thanks, guys. Thank you very much. Great.
Yeah. Giving John some participation.
You want to see the
Okay. Oh, yeah, of course.
So the future, basically, whatever we presented last time, it remains quite the same. We're gonna have 10 objects for FVD. We're gonna have. So we're gonna hopefully have 3D mapping of the system so that issues like that, if the chair isn't detected as an obstacle right now, that doesn't happen. And healthcare analytics, because we found out during our interviews that that's something an essential requirement in the facilities. And on 4th of May, along with Professor Zachary and Professor Jonathan Wiss, we're gonna visit Vitalia and we're gonna demo our robot. So that's something exciting that's coming up. And we're gonna thank, first of all, Dimi for your guidance last semester throughout. A lot of valuable advice, John, throughout the semester as well, through the team meetings and PRs, you have given us some valuable feedback through which we have been able to put the robot in the state it is. And then, of course, our advisors, Professor Zachary Erickson, Professor Jonathan Weiss, they have been through this, not just with us, with Team Turi as well. And they have helped us a lot and been very supportive because the hardware does not cooperate a lot, but they do. So that's been really essential throughout. And other than that, he's not here right now. He left home, but Greg Armstrong, the manager of the space, he's been really helpful as well. He has put his brains with us and trying to fix the hardware issues as well because he's good at that stuff. And then Team Turi, I think Josh is here. Is anyone else here? No, but yeah, Team Turi again, their stack was valuable because through their insights, we were able to sort of foresight what kind of issues we might face in the future and have a better risk mitigation in that aspect. So that's it. And Oliver Cromer, we had 3 of these stretches at one point in this space, and that's all thanks to again Professor Oliver Cromer. Without him, none of this would be possible. Essentially, this was very critical, and that's it. So thank you so much. Thank you.
Good job, guys.
Thank you so much. Thank you. Thank you.
Whoever else.
I'm so sorry.
No, that was good. That was good.
I just worried like or actually taking over.
Not at all. I think you want to test it, you don't limit any space, but midway through your
Not a problem,
why do you
I big briefly on Friday about the developing of our next week and that is our last week. The meeting next week as well. If you guys go off.
Something we have been trying to.
I think something we can yeah, it's like 6 o'clock and whatever. Pretty great. Waiting to see if I know there's a fan will switch here. Retreat. Yeah, we were like, just so we're clear, it's tiny lens, yeah, the light are moving up, and like the car there are reflected. So. Great. Exciting. Yeah, yeah. It's like, okay, we're done. One thing I think we should do is we should just let's go to Target and buy like a stack of ice cream cups. And then we'll bring the cups. That way you already know it's coming in the cup. Then buy like a stack of, like 100 cups or something, the cheap plastic. That is or bought.
Yeah.
Let's see it. Right there. Like the tape ring. The tape ring, yeah. Yeah, exactly. I'm thinking basically like the cup goes in it, it picks up like this, it picks down, it picks the cup. Something that's just rigid for me. I mean, depending on the cup, especially if you get something that sits like underneath the cup, so the cup can balance it. And yeah, I think that's fine too. I was just thinking that literally that's like top. That's one whatever, and like it goes in and as it picks up the liquid and then right. So anyway, it's a good stuff. And I like what is coming from heart, not the following. How are you?
And I just try to understand like growth. You want to improve technology and finance can also be in a try.
I actually don't know, so.
Yeah, okay. That's what I'm writing was, yeah.
We're all scared because you didn't wash your hands.
The last time, we actually got a lot of insights. All the notes and the sketch feedback to sum it up. And so a lot of them had things. That's why I asked you to come to and so on. As far as what is that's and I was thinking also well, you are saying and robot can get to that level that it's almost not good. So essentially you want to empower care going on that saving money that way, but I think you can make a case for
Well, I think, yeah, okay, I understand you have a business course and that has one particular angle on it, but if I could ignore that for a second, I think maybe instead of the saving money thing, this argument here, right? So it's like, let's say you have tenure, but there's certain things that we're taking care of. You're not gonna get rid of the nerves. But now your reputation for sort of patient care is better or higher because there's people like, oh, I'm doing their right? Yeah. So I think for the moment, don't come in with like, we're gonna let you fire your cheaper nurses. Yeah. And instead it's more about sort of